Today I'm going to talk about securing the Internet of Things. And the sort of silly title for my talk is Your Thing is Pawned. And I'm going to cover a number of different areas. I hope it's a useful talk. My aim is to be a kind of quite broad brush and then dive into one particular example that I've worked on in some detail, give a little demo, and then resurface back up and maybe draw some conclusions. So I hope that's useful. I apologize that I haven't got it in full screen mode because it's really annoying in PowerPoint when you switch from full screen mode to doing demos and showing screenshots and stuff. So I'm just going to have it like this, and you'll have to put up with my bar at the bottom. I always like questions, so if you have any questions or thoughts, just interrupt me or we'll do some at the end. So I guess the first question is, if your Fitbit is hacked, does it matter? Do we really care? Is the first question about these sort of things. And here's Dilberts' take on it, which is that, your management are going to use this to spy on you and give you more work. That's kind of typical Dilbert. It's quite funny, but it's actually quite real. This is a screenshot from 2011 where people were Googling who had sexual activity based on their Fitbit. And I'm trying to think, this guy here, I looked at one of these. One of these guys is called Chris. Luckily, he didn't put his full name into his Fitbit activity monitor. 10 minutes, not so sure. But anyway, I personally wouldn't really want this information to be visible, and I'm going to make this is possibly going a bit too far, but also, which hand are you wearing your Fitbit on? I have to ask you. Sorry. So my first 3 rules for IoT security. Firstly, don't be stupid. Secondly, be smart. And thirdly, think about what's different. So the first thing I want to capture is that there's a lot of things that web developers and internet developers a lot of mistakes they've been making for 20 years. And if you're an IoT developer and you make those same mistakes that everybody's made for 20 years, that's kind of stupid. So don't do that. And then my second point is, there's a lot of very good practice out there on the internet on how to do internet security. And of course, you need to use the best available practice. But that isn't enough because, of course, then there are the challenges that are unique to the fact you're dealing with a device, you're dealing with a thing, that there's some extra that needs to be dealt with. So those are my kind of 3 points. The basics of internet security haven't gone away. Use the best practice from the internet and think about what's different. So just to give some examples of the sort of being dumb, this is a true story. A web security internet researcher found that a lot of spam was originating from a particular IP address. They logged into that IP address and were presented with a smart fridge user panel. This was basically a fridge that had an internet access in it. You could log in and check the temperature of your fridge and things, and they just stuck a straightforward sort of Linux-style box in there, and they had port 25 open for SMTP, and some spammer had found this and was using this to redirect spam. So that's pretty weird, isn't it? That literally this fridge in someone's house was sending spam out. I found that just frankly cool. So another thing that's very common in hacking attempts, especially for IoT devices, is Google hacking. That Fitbit was an example. Does everyone know what Google hacking is? Google hacking is when you use a particular search string to identify a device that is compromised and can be hacked. So these search strings are all search strings that will help you get to people's private webcams and security cams they've put up in their houses, and get to see that that image, because these basically find feeds out of webcams. So this is another example of a hack that used Google hacking. There was a particular smart home automation system that had a hole in it. Now, actually, they had fixed the hole, but of course, being some device in someone's house, people hadn't upgraded. And that's one of the big problems with IoT, is people are not necessarily going to upgrade and reflash and keep your device up to date. So in this case, there was a Google hack that would find all the open smart home devices, and somebody found a list of about 60 that were open. And then he went and actually logged into all of them and found, I think it was about 20, where he could identify the home in which this smart home automation system was enabled. And he started phoning people up and saying, "Hello, I'm a security researcher. Which room are you in?" And the guy would be like, "Huh? I'm in the bedroom." And suddenly the lights would go off in the bedroom. And he basically owned their house, remotely, and they had no clue who this guy was. So this is kind of scary. These are very common. A lot of sort of internet-connected devices and home automation stuff use short-range radio, completely unencrypted, no security. So if your neighbor has one of these and you don't like them, you can basically force their heating on 24/7 and up their heating bill just by sending the right signal through a little $5 device that you can get off eBay. I'm not going to explain what this is if you can't guess, but this is another device that uses those same radio frequencies. Actually, somebody did a very cool hack to improve the user interface of this device using that. But there is actually now an internet-connected version of one of these devices. The VP of marketing was interviewed and said, "Well, what about security?" And she was like, "Well, I don't care." But, so what's different about IoT? The longevity of the device. So we talked about this already, about updates. The fact that people are not necessarily going to update the firmware. It may be very difficult to update the firmware on these devices. They don't have necessarily any UI where you can go through a process. Quite often it's a complicated model to reflash it. You sometimes have to get to JTAG headers and things like that. And the size of the device is very, very important. So especially around cryptography. And I'll talk a lot more about that in a minute. The fact it is a device, I think, changes the way people deal with it. Often these devices have no UI, no way of entering a user ID and password. And in order to have a very simple experience, the designers often go for the simplest possible way of registration or syncing up this device or saying this is my device, claiming it. And that is often the hardest part of this, to securely register a device and keep track of it. The data, as we've seen from some of those examples, is often highly personal. The systems you're using may really affect somebody's life. There's a lot of IoT being used in healthcare, where it's not just personal, but it's actually quite confidential. And with no disrespect to people on the hardware side, they don't often think like security experts. I think most app developers don't either, but they've been sort of forced into it. If you've been doing web app development over the last 10 years, you've been forced by multiple hacks and multiple news stories, and people are much better now about getting security scans and security penetration tests against their systems to know that there are a lot of problems, and that I don't think has yet hit the IoT community. And I also think there's a real problem with what you find when you go Googling and searching. So this is still a problem in the web. if you're a PHP developer and you Google how to secure my PHP app, the top 10, the front page of Google, every single answer is wrong. You go click on it, it says, start by opening up MySQL, create table, column, user ID, column, password, 32 varchar. Right? You do not go and store someone's password in a database table, but that's what the top 10 results all tell you to do. So, because they're old, they've been around for 10 years, and they've had lots of hits cumulatively, Google puts them up there, they're wrong. So it's much, much worse in the embedded design space where there really isn't anything like this. So I think those are some of the challenges. And some of the challenges around physical hacks. This is something called a Mifare Classic, and is used in the London Underground for your travel. So you basically charge it up with some money, and you go around, and it deducts money from it. If you go and get an Oyster card today, it's not a Mifare Classic 1K. It's a more secure version, but they have never switched off the old ones. So there are lots of these old ones around, and they're still accepted. And you can buy a blank Mifare Classic card for 50p on eBay. Turns out these are wide open. Some Dutch security researchers, what actually happened was their university decided to use this card as the entrance card for all the offices in the university. And being security researchers, they thought, well, let's have a look at this. So they took this card and stuck it in the university scanning electron microscope, and they had a look at the chip. And then they figured out what the algorithms were being used. They cracked it and reverse engineered the algorithms. Then they found a problem in the algorithm. And then the next day, they were walking in and out of their offices with blank cards, just hacked like that. Now, it turned out that the same card was being used to secure every nuclear power plant and every military establishment in the Netherlands as well. So they told the government, and the next day there were armed guards outside every single door of every nuclear power station and every military establishment that had one of these. NXP, who make this, tried to stop them publishing this data. Basically said it was against the commercial. It was going to harm their company to publish it, and the judge basically said, well, the harm is all in your product, not in the publication. You mucked up. The publication is not the harm. The harm is you built a product that didn't meet requirements. There's another one called a Mifare ultralight, which is used by the New Jersey Turnpike Authority, and actually you can use your smartphone to reset that and give you infinite free rides on the New Jersey transit system. It seems out that that's actually the same card used in our hotel rooms here. So if you're staying in the hotel, now I'm not, the hack on the transit system is slightly different from a hotel room hack, so it may not be hackable, but it's not necessarily the securest way in and out of your hotel room. If you don't want to hack them, there are companies out there, like these guys, who will do it for you. They basically offer to crack Atmel controllers, microprocessors, and so forth. So they will do it for you. If you want to have some fun, here's a plan on how to blast your Arduino chip with a high voltage and reset the lock bits on it so that you can read it. So I don't, this may catch on fire, so be careful, because it is a high voltage circuit, and do not electrocute yourself. So if you try this at home, I take no responsibility. If you want a slightly more academic view of this, there's a 65-page report from the University of Cambridge going through all the different hacks you can do on hardware and how to crack different tools. So one of the biggest lessons for hardware is not to rely on obscurity. That Mifare chip relied for the security on obscurity. So, in other words, they never expected anybody to do that. They never expected, oh, I'm sorry about this. They never expected anybody to reverse engineer their RFID chip and get into it. So, in fact, that's my major recommendation for hardware. Do not rely on obscurity. I could put it a different way. And I think this is an interesting way of looking at it. It's the same point, but said differently, which is unlocking a single device should only risk that device's data. So if you're putting a key on a device, a private key on a device, and you put the same private key on every device, and this is a cheap, $10 gadget that the criminals can buy 100 of and just keep trying to crack one until they get it, then at some point that device is going to be cracked and then you're going to be done. So what's the most famous example is probably the Xbox security. The Xbox had private keys for securing games and stuff on them. Eventually they got cracked. Same with DVD. So they're based on a model where every single device has the same key on it. Once you crack that key, then you're away. So that's my hardware recommendation. I'm not a hardware expert, but I think those are some very general rules. The next attack point is usually the network. We're talking about the Internet of Things. So these are network-connected devices. And the big problem with network-connected devices is the cryptography. So the standard cryptography that we mostly use is RSA. And if you do it on an 8-bit chip and you want to have a 2K key length, then you are talking 1,600 seconds to do a key operation. That's a long time for your device to sit just doing a key operation. So RSA is completely out. The other big challenge is the size of the memory, the ROM and RAM footprint. So, for example, some of these toolkits take up 29K of ROM. Well, my Arduino here has 32K of ROM on it. So it's not going to be much good. Of course, there are bigger footprints, but that's a big challenge. Now, elliptic curve cryptography can be much faster. So this is saying that you can do something that is equivalent to 1,500 bytes of RSA in 3.5 seconds. But that was using this library that takes 18K of ROM and takes quite a lot of RAM. You're going to have trouble fitting this on a small device. This is a chart I stole from a guy called Chris Swan, who's a CTO of various organizations in London, and he kind of summarized it rather nicely. There are these 3 categories of device. There's a sort of 8-bit Arduino-type devices, very common microcontrollers, and it just isn't going to work in realistic scenarios because of the SRAM requirements. There are the higher-end Arduinos that use a 32-bit chip, and it is possible, but it is not necessarily easy. The libraries and the keys and so forth are not all that simple to set up. So I haven't seen a lot of examples of people using these 32-bit controllers with, say, TLS. And then there's the full sort of Raspberry Pi, Arduino Yun kind of Linux OS type devices, and they are, give or take, no harder than any other device to do stuff on. The challenge really with them, and I'll get to this in a second, is key distribution. So you may say, well, okay, there are lots of these 32-bit controllers around. Isn't that just going to solve the problem? We're going to move away from these 8-bit controllers, low requirements. We just throw a bit more ROM, RAM, and processing power at it, we'll be fine. But that just doesn't, unfortunately, work because there's a significant cost difference. And that cost difference is going to remain, I believe, at least for 10 years, that the 8-bit chips are going to carry on getting cheaper and cheaper and cheaper as the same time as the 32-bit chips are. And so, the embedded system on chip inside a Raspberry Pi it costs about $25 retail. I don't know how much it is in volume, but it isn't much less. There's not a huge profit margin on these Raspberry Pis. They're very high volume, low margin product. The chip on a sort of Uno or an 8-bit controller, you can buy one of these fully fledged devices for $5 off eBay from China, and it's 50 cents, 10 cents or something to embed this. So it's very, very cheap. And I hear people all the time who need to create really mass products. So I have a customer who wants to put a water controller and monitor on every single plant in a farm, because there's a researcher who's discovered that if you water plants precisely throughout their life cycle, you get a 20% greater yield than if you just water them sort of randomly. So it's a huge difference. So now they're not going to buy a 32-bit controller to stick in the ground next to the plant, I can assure you. Apart from anything else, the power requirements of this are significantly higher than the power requirements of that. There are some other options. There are some hardware embedded devices that do elliptic curve cryptography. This is a chip from Atmel. It costs about 50 cents, and it does ECC. But there's no Arduino shield that embeds this. So that's tricky. There are some Arduino, there's no specific encryption shield for Arduino, which I think would be really nice. I'm not a hardware guy. If I was, I would be doing it. But there are some Wi-Fi shields that have encryption built in for the Wi-Fi, but it's only for the Wi-Fi. It's only getting you a protected link from you to the router. It's not getting you a protected link all the way to the server. There are some new algorithms, symmetric key encryption algorithms, published that are designed to help with small devices. The only problem is who created these algorithms. Do you trust the NSA to create a safe and secure algorithm? These were published literally about a month before Snowden started telling us exactly how much effort they go into I guess what was the word? Ruining good cryptography by doing their best to put backdoors into it. There is a UDP equivalent to TLS, and this is from a paper which says that you can do it with 16K of ROM and 4K of RAM. That's just for the DTLS. So that's sort of nearly possible, but it's still kind of on the edge. And I think the real problem in those key challenges is the key distribution. How do you get a client certificate onto every device? You have to do it at manufacturing time. So that's hard. You've got to somehow get all these keys onto the devices at manufacturing time. They're hard to update, and you're probably going to have to put a long expiration time on here, because you don't really want to have to say to people, you need to upgrade the certificate on your Fitbit. Because they go, what? So I saw the keynote earlier today, and I realized I didn't have enough pictures of cute animals in my presentation. So we're just having a quick kitten break while I have a quick drink of water, and you can enjoy this kitten. He had a lot of very good pictures of fluffy animals, didn't he? That's the only one, I'm afraid, sorry. So now we're going to move on to passwords. So passwords suck. We all know this. Every time you log onto a new website and it says, can you please create a new password to sign up for this site? and it's not meant to be the same password you've used before. And it's got this website has a different combination of complexity than the previous website. So you've got to have, I don't know, 3 uppercase letters, 1 numeral, 1 non-ASC, It just drives me mad. And they're really bad in lots of ways, but they're not designed for devices. Passwords are designed, the whole point of a password is meant to be something you remember, and you only produce when asked for from your memory. That's the design point of a password. It's not the design point for a device. So there are some solutions to this. And 2 technologies that have been gaining traction a lot are OAuth. Who's come across OAuth here? Okay, good. And who's come across OpenID Connect? About the same lot of people. That's because OAuth and OpenID Connect are actually the same thing. So this is kind of interesting. There was a plan to help get rid of passwords called OpenID, and it's never really taken off. But out of OpenID, they came up with a different model, which was how to protect device-to-device communication. So OpenID spawned this thing called OAuth, and OAuth was to protect device-to-device communication. And then OAuth 2 evolved out of OAuth. And then people started saying, well, actually, I can use this back to be an authentication mechanism. The way OpenID Connect works is you pass a token to a server, and it basically says you can go to another server and validate who I am with that token. And that converts it from a device authorization mechanism into a login mechanism. Because once the server goes and talks to that server and says, who is this? And it says, Paul Fremantle, I guarantee it. Then you've got a login system. The best example is actually, we're back to our little hotel room door key. An OAuth token is like a hotel token. This is a great blog entry from a guy called Kitten Break. Tim is a massively good guy. He's started doing XML. He's been very involved in RESTful stuff, and he's been very involved in OAuth and OpenID. And basically, the hotel room key, you show your passport at the hotel, and they give you this key, and it has very specific access. It gets you into your room for the next 3 days. And if you lose it, it doesn't matter because they can cancel that one and reissue a new one. If you stay too long, it doesn't matter because you can't get in the room anymore after that time period. And it's very specific access control to a particular destination. So this is what a token is. And if you're doing an IoT device with using HTTP as the communications mechanism, I would highly recommend using OAuth. Now, I typically use a different protocol for my IoT stuff. I like to use a protocol called MQTT. Who's come across MQTT? Okay, lots of you. Obviously, the indoctrination program run by Dominic on Monday has worked successfully, and also by Matteo. There's a lot of MQTT guys here today. And if you haven't come across MQTT, it's possible you've used it anyway, because all of Facebook's web apps, including their Messenger, use MQTT to communicate. You've also probably used OAuth at some point, even if you didn't know it. If, for instance, you've allowed a site to log on to use your Twitter as your logon ID or your Facebook as your logon ID, then you will have used OAuth. So in this case, what we're doing is basically there is a scope or several scopes that you are being asked to authorize this token for. It's not just a login. You see, this is actually basically letting one website do something on your behalf to another website. So it's letting this website read tweets, post tweets, see who you follow, and update your profile. I wouldn't actually, having read that, do that, because basically that's taking you over. The only thing it can't do is access your email and see your Twitter password. It basically has your Twitter account if you let it do that. I particularly don't like the update your profile and post tweets for you. That seems, I mean, this is an app that's meant to give you stats on your Twitter account. So it has to be able to see how many tweets you've done, see who you follow, and follow new people. Well, follow new people, that's also dodgy. So anyway, so there's a really important point here that I like. And I think this is a really important point for IoT, which I would like to see people build into their IoT thinking, which is this is giving the user the choice. Now, unfortunately, OAuth is not good enough in the sense I would really like to be able to say yes, yes, no, yes. I would love to be able to, on the fly, change that scope. Instead of just putting up with the scope that the website's asked for, I'd like to be able to say, actually, no, I want to change that. Now, there is a standard for that. It's called UMA, User Managed Access, and it extends on OAuth. But it's quite complex, and it hasn't got much adoption yet. But nonetheless, I would like you to think about when you build an IoT device that you are going to build this concept of user control into the device. So as you're going to say, I'm going to allow this Fitbit to do certain things, and I'm going to allow any websites that interact with Fitbit or any users who interact with Fitbit to do certain things, and I'm in control. And that's a very important point for privacy in IoT. So that's enabling a meaningful consent mechanism for sharing of device data. That's what I'm really talking about here. And there's a second aspect, which is that using these tokens are better than giving passwords. Because tokens are not just revocable, but they're also granular. I mean, passwords are revocable, but the point about a password is you're basically saying, this is me. You don't want to do that. You want to say, this is a device, and it has certain abilities on my behalf for a certain time frame. And that's very important. And I think there's two different aspects of this. There's the device talking to wherever it's posting data, to the web, to the cloud, wherever. And then there's the cloud talking to other cloud systems. So there's the Fitbit posting data onto the internet, is one part of the flow. And then the second part of the flow is people getting into Fitbit and getting access to your sexual activity or whatever it happens to be. So I built a little demo of this. And what I did was I basically built the demo to explore the challenges of using this web protocol, OAuth, with this non-web technology, MQTT, that's being used for IoT. And to explore what happens when you try and do it on a small device like this. And so what I have is a sort of step where there's basically, the first step is I have to encode the token onto my device. So that's the manufacturing process, or a device management process where I have to somehow get the token on there. And then there's the Arduino publishing to the MQTT broker. And in this case, what I did was extended the MQTT broker. I used a broker called Mosquito, and extended it with a OAuth 2 plugin that talks to something called a WSO2 identity server that implements the OAuth protocol. And I did have a little hack in the middle, which is I can tell you about later if you want, but it's not. It's just a sort of simplification process. The other aspect, so this device to the cloud, so I'm going to get the OAuth 2 token onto the device, and then I have to apply a scope to that token. So I'm going to say this device can write, say, data to a particular topic, and that's all it can do. So anyone who hacks the device can't read data from that topic. They can't write data to any other topic. It's just that topic. And an important challenge for this is that OAuth 2 has this concept of a refresh token. So you actually get two tokens. The first token lasts for a certain amount of time, and when it expires, you have to go and refresh it. And the problem I had was that the MQTT code takes up about 15K on here, right? And then I have, I'll show you a picture of it. Actually, I've got a picture of this thing here. So what I have here is I've got an Arduino Uno at the bottom, and then I have an Arduino Ethernet board, And then the top is actually doing something. So this is a fitness tracker. Okay, it's a little bit big and bulky to carry around, but it's got a 9 degrees inertial measurement unit. So this is basically measuring the movement of this device and publishing it to MQTT. And the code for the IMU took up, so basically the code for MQTT and the IMU took up 97% of my code on the Arduino Uno. So then to say, well, okay, now I'm going to use HTTP to refresh my token when it expires, doesn't fit. I hadn't got any room for HTTP code as well. So what I did was I moved the refresh code to also use MQTT. So I changed the OAuth model to use this MQTT to do a refresh. This is basically the defining this application in the identity server. This is the OAuth 2 setup for it. So this is not a very slick demo. I'm a CTO, which means that my coding skills are very rusty. My development team won't let me actually. They haven't actually removed my commit rights yet, but I know they want to. So this is kind of a messy demo, but it's just to give you a bit of a flavor of it. So what I have, if I just get, just pop that down. So I've got this is my MQTT broker, and it's in full logging mode, so it's showing me everything that's happening. And what I have is a little utility that's listening for refresh requests. And it's basically when it gets that refresh request, it converts that into an HTTP request against the identity server, gets the real token, and then it republishes it back to the client on MQTT. So what's going to happen is I'll show you 2 steps. I'll start out by hopefully using what's working, and then I'll maybe break it for you. So I plug this device in, and the first thing it does is it tries to connect, but its token is now dead because it's out of date. So then it disconnects, and it actually republishes to the refresher. And it basically says, here's my refresh token. And then it sends back, you get back a new publish back to the token, and it disconnects again. And then for various reasons that weren't very good, I then kind of left it for about a bit of time for it to put in a little block before it then refreshes. And then in a minute, it should start sending messages. Hey, here we go. And so this is a utility tool, MQTT Lens, that allows you to view MQTT publishing, and you can see that it's getting updates from here. It's a little slow because I don't have any caching. So every single message is being validated by a request against the identity server. So the caching would be a good thing to add. And also the MQTT Lens is actually not super fast. So that's the basic flow in runtime. I will briefly try and show you the setup process, just to give you an idea. This is also not necessarily great. So what's happening here is I'm starting a command line utility, and the important thing here is that the command line utility has to redirect you to the authorization server, because this is asking me to type in my credentials. Now, of course, in an automated configuration in a manufacturing process, you would automate all this. But I wanted to show you how this is my personal thing. And what I'm going to then have to do is log into this. And I'm logging as admin, which is not quite right. And it's basically saying this utility has asked for access to this scope. Now, again, a bit of a hack. Basically, I encoded the actual scope into into a JSON. I basically created a JSON that said this device is asking to be able to publish to this particular topic and read from these topics. But the JSON format is incompatible with the scope format, which is space delimited. I could have done something else, but as a quick and dirty thing, I just base64 encoded it. So then it says, right, now you have to get this token into your Arduino. And the way I did that is I basically, there are better ways than this. There are utilities you could write that would do it, but I basically created a little sketch that just, I just delete that, cut and paste the new one, and this just writes it into the EEPROM. So I run that sketch, and then when I load up my normal default code, it loads that refresh token out of the EEPROM. So there we go. Fairly straightforward. So the cloud to the app, the same technology, of course, can then be used to say, well, who can now get that data out of the topic hierarchy? So that broker I've created that has that OAuth validation in it won't let anybody read those messages from this device unless someone else unless the authorization server gives them an OAuth token. So that's important as well. So some lessons learned. That was what I did this for, not to create a demo, because as you can see, that wasn't really very engaging. But the OAuth 2 token lengths are usually okay. They're about 40, 50 characters, depending on which server. One of the problems is the OAuth spec doesn't say what a maximum is. So you could get an OAuth token server that gives you back a 5K token, and that would not be very good on a device that has 8K of flash. OpenID Connect also uses OAuth 2 tokens, but they're much, much bigger. So that's a bit of a challenge for these small devices. Registration is hard. That registration process was fine for me to show you. It's not exactly what you want to do to somehow flash your, to update your Fitbit. You need to have a much, much smoother process with some, preferably with some cloud service which will dump it down onto the device. As I said before, the MQTT and I2C code was 97% of this device. For adding the final logic to do the OAuth 2 flow was actually not very much. It just pushed it to 99%, but that's because I used MQTT. Now, I have to give you a big warning. This demo did no TLS. So all of that was unencrypted. So that is breaking the OAuth 2 spec. That is a big problem. But you've got to split problems into orthogonal issues. TLS is a big issue in any device. It's not a problem I was trying to solve, so I chose to ignore it. But it's not saying it's not an issue. There was some interesting variability in the OAuth 2 token flow. So the OAuth 2 spec has some choices in it, and I found out that these choices really matter in this use case. Because when you do a refresh, you're passing over this refresh token, and it's giving you back a new access token, okay? At that time, some OAuth 2 implementations will give you a new refresh token as well, okay? Now, this is all done in the OAuth 2 spec over HTTP, which is non-reliable. So if your OAuth 2 implementation does that, and you lose that message, then your device is now stranded, because it has the old refresh token in its EEPROM. The new refresh token didn't get to it. It sends the old one. The server says, oh, I don't know about that token. That token's dead. I don't trust you. So this is a real challenge in this spec for devices. This is a technology that was designed for the web. Lots and lots of times, I use something called Bitly to capture links and share them to Twitter and Facebook. And about once a month, it says, sorry, your link between Bitly and Facebook has died. Can you refresh it? And I just go through and I click, I approve, and bang, it's back to working. that's not going to work with a device and a thing. And the other problem is MQTT is very good in lots of ways, but it's really bad at RPC. So I had to kind of come up with my own way of doing RPC and write a special security handler to secure it, and it was a lot of work just to get a message back to one device in a secure way. So that's something that really needs working on in MQTT. If you want more details, there's a blog on my blog about it, and I'm presenting a more sort of academic paper next week at a conference, Secure IoT workshop, and that will be published in due course. If you want a copy, I can send you one as a postprint. So I just wanted to talk about one more aspect, which is sort of not, I think we've kind of got the IoT bit. I just want to mention this briefly because of the mobile connection. We're at a sort of shared mobile conference, and I know a lot of the IoT devices talk through mobile phones. There is we talked about OpenID Connect. The really important difference between OpenID Connect and OAuth is this concept of a chooser. OpenID Connect, today you go to loads of websites, you've all seen them, that say you can sign up or you can use your Facebook or Twitter account or GitHub account to get on board, right? But those are hard-coded to those particular providers. And if I was a startup, I would not like to really do this. I mean, I'd love to do it because it means I don't store anyone's user ID and password, so I can't get hacked. Why don't I want to do it? I don't want everybody clicking on Facebook. And now Facebook has all my business stats. They know how many new people sign up to my service a month and how many people keep coming to my service a month. And if I'm a startup, I don't want to give my that's my core business information for any new startup probably. You're basically giving it to Facebook. So what OpenID Connect allows you to do is to have a generic thing on there, and people can choose their own provider. It could even be an IDP running on your mobile phone. So you could actually run an IDP on your mobile phone is one of the options that they're looking at. And they've extended this to Mobile Connect. And the idea of Mobile Connect is that your phone number and your phone become your identity provider. So this is really nice. So what happens is the first time you use this, they send something called the USSD code. It's like a sort of lower level than SMS back to your phone with a number. You type that number in, and that goes to your phone provider, and then they act as, say, yes, this is Paul. And then this becomes a single sign-on to any service that has added this. And the idea is meant to work across all different phone providers. So you put your phone number in, and it discovers which provider you're with, and then routes it to them. This just launched in February, and it's slowly gaining traction. There's a first prototype service. Well, it's a real service, but it's a very limited, small user group, actually running across 4 different phone vendors. And we're the technology provider, so we're pretty pleased about that. And we're trying to help the GSMA as well do this. So if you're doing anything that's got a mobile angle to it, I really think you should look at Mobile Connect and OpenID Connect as login models of really trying to disrupt this tie-in either to your database and password, your user database, or just Facebook, Twitter, Google, who tend to be the ones everyone uses. So if you're making a device, I think it's really important that you have this model in mind. And I'm feeling the same way with this OAuth 2 MQTT code, because I want to do some formal analysis of it, but I have a feeling that there may be some, things that I've added to it that might have some issues, because it hasn't been through the peer review. So the really important thing here is that you need to use tried and trusted security stuff, but you also really need to think about the long-term implications of what your device is going to do, especially if it takes off. I think that was what the Fitbit guys didn't think about. Their initial thing was, we're going to publish everyone's Fitbit activity publicly. by default. So the minute you get a Fitbit, unless you go and switch it off, we're going to publish all your activity to the web, and anyone can see it. And that was a mistake. You know, it was an understandable mistake. They wanted to get this going, and they were just a few people, and they probably, they did Kickstarter, and it was all fun, and they didn't have that long-term vision of what happens if this takes off, and millions of people are wearing Fitbits, and now you can track what they're doing. So I'm not trying to scare people here. I want, if you go back and look at the history of new technologies, every new technology, somebody stands up and does a sort of scaremongering and says, security. If you think about cloud computing, everybody's like, oh, security. Think about client server or the web. Yesterday there was a keynote by a guy, and he was talking about how, he started thinking about stock trading on the web back in '94. No one would have believed that was possible if you went to any of the stock trading companies in '94 and said, they were all saying, no, it can't be done, it's not secure. I remember all the banks doing weird, complex, very, very difficult security stuff on the web that just didn't work because they didn't believe in web security, in standard web security models, and they didn't want to improve them. So everybody, a new thing comes along, everybody always uses security to bash it down. And that's not the aim of this presentation. That my aim here is to say we need to do the right stuff, but also we need to help bootstrap that world. So when you Google IoT security in 5 years' time, I want the top 5 hits to be good. I don't want them to be create database table password. And when you Google, how do I secure my MQTT Arduino, I want there to be a good exemplar. I would love there to be some shields for Arduino that embedded really good security, so that guys who are not really software developers but understand hardware are going to grab these things and create secure stuff. So I want you to think about security, and as a community of IoT people, what I think we need to do is to make sure the next generation of IoT devices are secure. And when we do that, as we create these new things, we need to publicize them, we need to make code available, we need to create open source, we need to work in the standards bodies to push this out, we need to help create shields and so forth. So that's my mission, that's my call to action to you guys. You're part of this. When you do this, try and think about how you're not just helping your own project, but helping the community and helping improve the security, because that's going to help everybody make the whole IoT space more secure. And then in 10 years' time, we're going to live in a world where there's a good trust in these devices. And one last plug. If you want to know more, you can come to our stand just outside. And we've published a reference architecture for the Internet of Things using our technology. But it's a general reference architecture that you may find useful as well. It's not just about security. It does talk about security, but also communications, event processing, device management, and so forth. All right. Any questions?
Great talk so far. One question. It's always hard to, so as soon as any attacker has physical access to the device, it typically is gone. What's your spin on that? You just say make sure it's not a problem with the device gone and not under control, or what's your...
So let me repeat the question because not everyone could hear. The question is, when you have physical access to a device, it's almost impossible to secure that. So a determined person can break into that device. So what's my take on that? And my take is exactly the first thing you've got to do is to make sure that that doesn't spread. So taking that device doesn't mean that you've got any other device or any other person's data. So that's the very, very most important challenge, is to say that I kill that device, but it doesn't spread anywhere else. There are obviously lots of attempts to make devices tamper-proof, but they're very, very hard. You know, you saw those guys who will, you know, put your device under a scanning electron microscope and flip individual bits in the ROM, in the flash, the lock bits. They can flip them off with the electron microscope, and then it's unlocked. So there is no real protection against that one device. So you have to, I mean, obviously, if it's important to the person, you have to tell them, you know, don't let someone steal your device. But if you just have to stop it spreading. That's the only thing you can do.
So what are you proposing for an end-to-end solution? So you skipped out transport level security, and I do not know how tamper-proof your MQTT broker was. So is it possible with a small Arduino device to add all those code, or is Arduino just not a qualified device architecture for an IoT device?
So this device doesn't do TLS, but you know, it would be possible, for instance, to add that ECC chip to this and do elliptic curve cryptography on here in a reasonable price factor if you're a good hardware hacker. The problem is, if you're not a good hardware hacker, there's no, you know, there's not an easy just bolt-in solution for that. So that's an unsolved problem today, is how to cheaply do TLS or DTLS from any device, and that's a big research problem. So but end to end, yeah, the answer is you've got to have a client certificate on here. No, sorry, not a client certificate. You've got to have a server's public certificate on here so you can initiate a secure conversation. That's okay, that's easy to get on there. You have to get some way of getting this token onto this device and managing the token on the device. And then you basically have a secure publish to the MQTT broker, and you obviously make sure that anyone else connecting to the MQTT broker in the cloud is also using TLS. And then the OAuth basically matches, you know, who can read this data, who can write it, and you have to make sure your MQTT broker is secure. I mean, if someone hacks in there, then they've got everything. So, you know, it's standard web security. You've got to, I mean, in web security, you've got to hit every little point on the way and look at all the different aspects, and the same is true here. For this demo, I only chose to target one particular aspect because I felt that had not really been looked at. So I was trying to solve that little problem. I would love to solve the sort of cheap TLS problem, but it's more of an engineering problem than a computer science problem. Computer scientists like to say, well, I know how it would be done. That's fine, that's enough. Engineers like to actually fix the thing, and I'm not enough of an engineer to build a shield, so an effective shield. So that's where I would pass the buck on to someone else. Yeah. Okay, I'd just like to summarize. So I think, you know, we talked about the hardware challenges, the network challenges, some of the design challenges, and then I dived right into a particular aspect, which is using federated tokens with IoT, which I think is very important. But I just want to leave you with the overall message that there's lots of different challenges, and you need to think about all these if you're designing devices or you're participating in an IoT project. So thank you very much.